Okay, year 9. Just like I did for circles, I want us to spend some time just looking back over what we've been learning in this section of algebra. So solving equations, and this will just help prepare us for our test that's coming up. So the first thing we looked at was just solving equations. Now remember, whenever you're solving an equation, it means that you have to find what the value is of the unknown. Now the unknown will always just be a letter, and the majority of the time that letter is x. So if you're asked to solve, that means you have to figure out what the value of the x is, or whatever letter that the question is using. Okay, so in this first one here we had 4x plus 7 equals 19. So if we're looking to get x on its own, we need to do the opposite of what is currently happening to x. So at the minute x is getting multiplied by 4 and then 7 is getting added on. So we need to do the opposite of both of those things in the opposite order. So the first thing we need to do is to get rid of this plus 7. So the opposite of plus 7 is minus 7. So we're taking away 7 from both sides. And we draw our lines down the side, show what we're doing here. So we were taking away 7 from this side, and we're taking away 7 for this side. And the reason we'll have to do it to both sides is to keep everything balanced and to make sure that the equation still stands. We haven't changed it in any way. So if I take away 7 from this side, all I'm left with is 4x. And then on the right hand side, I've got 19 and I'm taking away 7, so I'm left with 12. Then we need to get rid of this 4. So 4x means that x is being multiplied by 4. So we do the opposite of that and we divide by 4. And we do that to both sides. So we end up with x equals 3. Because 4x divided by 4 gives us x. 12 divided by 4 gives us 3. Now, all the rest of these examples are just following the same rules. So question 2, first of all, 3n minus 5 equals 7. We have to do the opposite of this, so we have to get rid of this minus 5, and the opposite of minus 5 is plus 5. So that just leaves us with 3n on the left hand side, and then 7 plus 5 gives us 12. So the opposite of multiply by 3 is divide by 3. So that's why we've done that, and we do that to both sides, and we end up with n equals 4. Now in these next examples, there's a couple of extra steps that we have to do to tidy up first before we can go ahead and solve the equation. So in this one here, we had 5c plus 5 equals 9c minus 3. So we need to gather all our c's together on one side of the equal sign. Now the general rule, if you remember, is that you gather them on the side that has the higher number of c's. So see the way I've got 9c here and I've got 5c here. I opted to take 5c away from both sides because I knew I was going to end up with a positive number of c's here. Whereas if I had decided to take away 9c from both sides, I would have had 5c take away 9c. It would have had minus 4c over here, and it just would have been messy. It would have been more difficult for me to solve, because we would have ended up with a lot of minuses. Okay, so general rule, try and gather your letters on the side where you have the bigger number of them. So we're taking away 5c from both sides, so if I get rid of that from my left hand side, all I'm left with is 5. 9c, take away 5c gives us 4c. Now we can't do anything with this 3 because that's nothing to do with the c's, that's just a 3 on its own. Okay, so it just stays there as a minus 3. And now this stage is where we were starting at up here. So we're back to what we were doing there in examples 1 and 2. So c is getting multiplied by 4 and then 3 is getting taken away. So that means we have to do the opposite of both those things. So the first thing is the opposite of the minus 3. So we add 3 to both sides. So 5 add 3 gives us 8, and then we're left with 4c here. The opposite of multiply by 4 is divide by 4. So again, we've divided both sides by 4. Okay. Example 4, we've got 3n minus 7 equals 33 minus 5n. So this is an extra complicated one. Do you see how we have got 3n on this side and we've got minus 5n on this side? Well, that tells me I'm going to want to gather my n's over here, because if I was to take 3n away from both sides, if I have a wee quick look before I do anything, that's going to give me minus 8n on that side, and again that's quite awkward to work with. So I'm going to try and make life as straightforward for myself as possible. So another little rule is if you have a minus number of n's or a negative number of n's, it's always easier to add those to both sides so that you're working with positives as much as you possibly can. So that's why I've added 5n to both sides here. Okay, so 3n plus 5n gives us the 8n. Doesn't affect the 7, that's nothing to do with the n's. And then on my right hand side I'm just left with 33 because I've minus 5n plus 5n. Okay, so again now here we're at the stage that we were starting at earlier in our earlier examples. So n is getting multiplied by 8 and then 7 is getting taken away. So I need to do the opposite of those. I add 7 to get rid of this, which gives me 8n. 33 plus 7 gives me 40. And then I have to get rid of this 8. So the opposite of multiply by 8 is divide by 8. So whenever I divide both sides by 8, I get n equals 5. Okay, so our next step was solving equations which had brackets in it. So this was putting to use our solving equation skills, but also our working with brackets, which we had done in the original algebra unit, the one that we did a little while ago. So with these ones here, there's another added complication. So if you remember, if you have something immediately beside a bracket like that, it means everything in this bracket has to be multiplied by the thing that's beside it. Now it doesn't involve this bit here. A lot of people will make the mistake of simplifying that to 5 brackets x minus 2, but that would be wrong. It's only the 2 that gets multiplied on. And if you remember the way that we say that, we say, I would read that as 3 plus 2 upon x minus 2. Okay, so in ones like this that involve brackets, the first thing you have to do is multiply out your bracket before you try and solve anything. So that's what I've done from this line to the next line. So 3 plus, and then I've multiplied 2 by x to give me this 2x, and I've multiplied by 2 by minus 2 to give me this minus 4, and then that's equal to 5. Now before I would go on and solve, to see how this has got two terms which are the same type together, so I can tidy that up before I start to solve my equation, before I start to do things to both sides. So 3 plus 2x minus 4, I can gather together my 3 and my minus 4, because 3 take away 4 gives me minus 1. So that's where that has come from. So I can simplify this down to 2x minus 1, and that's equal to 5. Now we're at the solving equation stage. So x is being multiplied by 2 and then 1's getting taken away. So we do the opposite of that. We add 1 first of all, and that gives us 2x equals 6. And then we divide both sides by 2, and that gives us x equals 3. Okay, example 2 down here. This time we've got two brackets. It's exactly the same process, just take your time, don't rush. So the first step, as before, is to multiply out the brackets. So 3 multiplied by p gives us 3p. 3 multiplied by 1 gives us 3. Minus 2 multiplied by p gives me minus 2p. And then minus 2 multiplied by 2 gives me minus 4. And that's all equal to 7. And again, before I try and solve anything, I will tidy up. And that's what these wee lines are. Whenever I have lots of things in an equation like this, I will quite often score them out as I'm gathering them together. So what I will have done here will be 3p take away 2p gives me p, and I'll have scored those out as I go so that I know, right, I've dealt with those ones. And then all I have left are the 3 and the minus 4, and 3 minus 4 gives me minus 1. So that's how I've gone from this line to the next line. So p minus 1 equals 7. So we add 1 to both sides, and we end up with p equals 8, and there's no more steps on that one. Now we added in this extra example in our notes, so let's have a little look at it. So one's like this, where you've got two brackets and they're on opposite sides of the equal sign. Same as before, first step, multiply out your brackets. So 2 multiplied by x gives me 2x. 2 multiplied by 5 gives me 10, equals 6 multiplied by x gives me 6x. 6 multiplied by 1 gives me 6. Now, we can't really tidy anything together on the left side, solving our equation. And do you remember the rule we just said about how it's easier, if you have two positive numbers of x's, it's easier to gather them together on the side that has the most x's? That's what we've decided to take away 2x from both sides. Okay, so taking away 2x from this side gives us 10, equals 6x take away 2x gives us 4x, and we still have this 6 here. Remember, that doesn't affect that. Then, to get x on its own, we take 6 away. We need to get rid of this. So we've taken 6 away from both sides. So 10 take away 6 gives us 4, and we're left with 4x. Then our next step to get x on its own is we divide by 4. So 4x divided by 4 gives us x. 4 divided by 4 gives us 1. So we're left, we've got x equals 1. Okay. So the next thing we did was, well, really we were multiplying and dividing algebraic fractions, but we spent a little bit of time reminding ourselves of the rules for multiplying and dividing normal fractions, so just fractions with numbers in them. Okay, so just to recap that super quick, if you're multiplying fractions, you just multiply the top by top and bottom by bottom. So 3 multiplied by 6 gives me 18, 5 multiplied by 7 is where that 35 has come from. And to divide by a fraction, you turn the fraction you're dividing by upside down and then multiply. So this question was originally 3 over 4 divided by 9 over 11. Now normally, you know, I would be saying to work down the page, but because we didn't have room, we worked across the page. Don't tell Mr. Marshall, don't let him see this video, hopefully. So, I've turned going from here to here, I've turned my second fraction upside down. So my 9 over 11 has become 11 over 9, and I've changed it to a multiplying sign. Now, only once you've done that can you start to simplify anything. You cannot simplify your fractions at this stage here. You can only do it once you've turned the second one upside down. So because we had something on the top line and the bottom line, then we could simplify, because 3 will go into both of these numbers. So 3 divided by 3 gives me 1, and 9 divided by 3 gives me 3. Now if you're doing that, you can only do it with one number from the top and one number from the bottom. You can't do 2 numbers from the top or 2 numbers from the bottom. So anyway, 1 multiplied by 11 gives me 11, 4 multiplied by 3 gives me 12. So on to actually working with algebraic fractions. Now algebraic fractions just means that they are fractions that have letters in them, and it's not just all numbers. And before we look at those, we need to remember that all of these things here actually all mean the same thing. So if you're asked to find, for example, 1/6 of something, that just means you would multiply that thing by a sixth. And that can be written a sixth x, or it can be written x divided by 6, or x over 6, like that. They all mean the same thing. So don't let the wording of questions put you off. Now, these examples look quite messy because I've already filled them in. But we'll follow on. I'm glad I used different colours whenever we were doing this in class. So for example 1, we've got 14 multiplied by x over 7. So the first step is to rewrite this 14 so that it looks like a fraction. So 14 as a fraction is 14 over 1. Okay, so 14 over 1 multiplied by x over 7. Now, before I did anything else, I simplified here, and that's what I've done in my pink pen here. So 7 will go into both 7 and 14. So 14 divided by 7 gives me 2, and 7 divided by 7 gives me 1. So now all I'm doing is multiplying top line by top line, bottom line by bottom line. So 2 multiplied by x gives me 2x, and 1 multiplied by 1 gives me 1. So 2x over 1, I can just write that as 2x. Okay, let's work our way through the rest of these examples. So, a quarter of 8x, remember, from up above of just means multiply, so a quarter multiplied by 8x, but I've also rewritten that as a fraction, so 8x we can write as 8x over 1. And then, do you see how we could simplify here? So both 4 and 8x could both be divided by 4, and one's on the top and one's on the bottom. So 4 divided by 4 gives me this 1, and 8x divided by 4 gives me this 2x. So from this line to the next line, all I'm doing is multiplying top by top. 1 multiplied by 2x gives me my 2x. 1 multiplied by 1 gives me 1. So that gives me 2x. So number 3, we have 3x over 4 divided by 6. So the first thing is to rewrite this with our 6 written as a fraction. So 3x over 4 divided by 6 over 1. Now we can't simplify at this stage, so we have to turn our second fraction upside down and change it to multiply. So our first fraction stays the same, so 3x over 4, 3x over 4. Divide has changed to multiply, and our second fraction has turned upside down. Now that we've done this, now we can start to cancel. So we saw, whenever we did this in class, we saw that 3x and 6 could both be divided by 3. So 3x divided by 3 left us with x, and 6 divided by 3 left us with 2. Okay, so x multiplied by 1, I should be working down but I ran out of room, gives me x. 4 multiplied by 2 gives me 8, and we can just leave our answer like that. Now if we'd forgotten to cancel at this stage, that would be fine. We just would have had an answer here that would need simplified or cancelled. So it's okay if you leave it to the end, but if you leave it to the end you might find you've got big numbers that you're working with, and it ends up being a little bit more tricky. Okay, so example 4 was 4x over 5 divided by 8. So again, first thing I've done is just rewrite this 8 as a fraction, so it's 8 over 1. Then I've turned my second fraction upside down and changed my divide to multiply. Now that I'm at this stage, now I can simplify. So 4x and 8 can both be divided by 4. So that gives us x here and 2 here. And then x multiplied by 1 gives me x. 5 multiplied by 2 gives me 10. Then we took our algebraic fraction skills and our solving equation skills and put them all together. So the next thing was solving fraction equations. So we started off with questions like this, where we've got x over 7, so x divided by 7 equals 3. So the opposite of divide by 7 just means we have to multiply by 7. So we've multiplied both sides of our equation by 7 to give us x equals 21. Then, question 2, we've got very similar, x over 6 equals 4, so that means x divided by 6. So we've multiplied both sides of our equation by 6 to give us x equals 24. Now, for example 3 and 4 was stepped up a notch. So let's look at 3 first of all. So we've got 2x over 3 equals 6. So there's more steps that we need to account for in this one. The first thing I would always do would be to get rid of anything on the bottom line. So I need to multiply both sides by 3 because x is currently getting divided by 3. So if I multiply both sides by 3, then that leaves me with 2x on the left hand side equals 6 times 3 gives me 18. Now we're all familiar with these. So if 2x equals 18, we just divide both sides of the equation by 2, and that gives us x equals 9. Okay, example 4. We've got 3x over 4 equals 2/9. So this is where we start to bring in our multiplying fraction skills. So 3x over 4, first thing we need to do is get rid of this 4 in the bottom line. So we've multiplied both sides of our equation by 4. Now, this looks super confusing, but it's not. On my left hand side, I've got 3x over 4 and I'm multiplying by 4. So that just gets rid of that, divide by 4, and I'm left with 3x. Now here I've got 2/9 and I'm multiplying that by 4. So whenever we did this in class, that's all I will have written. But then I will have reminded us all that 4 we can rewrite as a fraction as 4/1. So a lot of time people will ask, well, hang on, where's that come from? That's just me multiplying by 4, but writing it as 4/1. And then we can use our fraction multiplying skills to solve this. So my next line from here to here, this has stayed the same. All I've done is multiply these two fractions together. So top by top, 2 multiplied by 4 gives me 8. Bottom by bottom, 9 multiplied by 1 gives me 9. Now, from this step to this step, I've divided both sides of the equation by 3. And again, looks super confusing, but if we slow it down and take our time, it's not too bad. So 3x divided by 3 gives me x. 8/9 divided by 3, I've just rewritten it. I've written it out, but I've rewritten it as a fraction over 1. And again, I would be working down my page, but I ran out of room, so I've snuck up here. So this line, 8/9 divided by 3/1, dividing by a fraction, remember, turn your second fraction upside down, so 3/1 has become 1/3, and divide has changed to a multiply. Then I'm ready to do that. So 8 multiplied by 1 gives me 8, 9 multiplied by 3 gives me 27.
Well, 9p, here's a picture of my dog, just to look at while I tell you that I don't know where the rest of my video's gone to. It seems to have disappeared. Now, luckily, the bits that cut out are the bits on working with equations with decimals and also on inequalities, which there's videos on those things already up here. So if you find those tricky, then you can scroll back and find those videos. Okay, speak to you soon. Bye.